Okay.
Hello everybody. Today I'm going to forge a small knife out of this piece of a regular, normal little file. This is half a file, really. I'll start by heating it up in the forge. And as this is going, I'll be working on a second one, which I've already started, but I can talk through what I'm doing here. I'm going to grab with a different pair of tongs, because then I don't have to be as close to the heat. A lot of the time I bring things out, set them on the bricks so I can grab a better grip on there. And this one, I have already forged out the part that looks like it'll be the blade. And I'm making a tang right now that I'll end up curling back into itself. But I have to keep heating and hammering and tapering to make it small enough that I can curl it back. It does tend to curl a lot as this goes on. Alright, now at the very tip here, it looks like it might be a little bit yellow. That's about the right forging temperature. I want to grab it really well though, because I'm going to be hitting it rather hard and I don't want it to pop out and hit me in the face. So, let that heat up just a touch more. And my first step is going to be forging that to a point. Re-grip here. Doing great. There you can see the point is starting. When I heat it up again, I'll forge on the opposite side right here to try and point that down a little bit more.
Is it okay if I talk to your crowd about...
Of course.
Good afternoon, everybody. I hope that you guys are doing okay. So this is Science in the Market, and we got this forge, and we have Bill and Patricia there who are very kindly demonstrating what's going on with the translating metal. But, Bill, you work only with steel, right?
Yes.
Pretty much, right? So steel is made out mostly of what?
Iron.
Iron, all right. But iron by itself, if I were to get pig iron, is it going to be good for working, metal working?
No.
Why?
Because it'll be too brittle. You need iron, or you need carbon added onto it.
Yeah, so if you have, for instance, if iron is made out of a lattice of essentially iron and stuff like this, by itself you can imagine you can essentially kind of like chop off by shock and actually separate those atoms together. One way of making iron stronger and turning into steel is by adding carbon in it, right? So carbon is an element. You and I have quite a bit of carbon in our system, along with water, nitrogen, oxygen, things of this nature. So what you do is that you kind of like jam a carbon atom into this lattice to keep this guys from actually shifting, and that's what gives it strength, right?
Yes.
So only 1%, just 1 in 100 is enough to actually keep this thing together. If you put too much carbon, it becomes brittle again.
Yes, it does. I'm going to go ahead and forge the other half of this tip down. I'm working it on the edge of the anvil here so that I can kind of hit at an angle and it'll just bounce off to the side. It's quite heavy right there right now, fat on it, so I'll have to hit it down again and again. And it's already gone pretty much black again, so it needs to heat up. I heat it up until it's orange or almost yellow every time, and that makes it so much more pliable. And I'll show just how pliable it is. I can take this with 2 pairs of pliers and just twist it around and around and around. And that'll add a neat little detail on there. And he was talking about carbon, but that carbon also will come off and fluff off. And all the impurities that are in the metal as I'm working it, they'll flake off like that. back up again. The nice part about working multiple projects is you can make the most of your time. While one piece is heating up, you can work on another. So now that this is forged to a tip, I want to try and forge in a bit of a bevel. Bevel! Not a bevel. Alright, now my other piece is warm enough that I can grab it back out.
How hot you think this forge is?
About 1500 degrees, so it's quite warm. I don't want to touch any of that with my bare hand. Otherwise I'll get burned so bad I won't feel it. Now I'm just hammering out where I twisted it again. And it creates a nice texture. It'll look quite pleasing to the eye.
Oh, yeah.
Good, how are you folks? Back to this knife that I've been forging on. I don't like how that's curling up there, so I'll tip that back down a little. Now, I'm just trying to get it flat because it's half round on one side and flat on the other. I want it to be flat down both sides. So I have to keep working it. And I'll also work this tang to make it come and curl back around. So it's just like this one, the one that's in progress as well. Now I'm isolating it after twisting it. That got a little bit lost there where my edge is. So putting it on the edge of the anvil and beating it a few times just to create that shelf again. Right there, that little spot. And this is now to the point where I can start working on a little twist on the end here. I might just flatten it out a little bit more and then do that. And what do we know? This guy's ready. I want to start moving some of this material, which I just touched, out. It's kind of folded into itself. I'll then pound it flat. Chop into it again like that. And now I think I need to heat it up again. But I'm starting to isolate some of this material and I'll move it outward. I want to make this a tiny, tiny little tip. It's nice and square. Turn it back around on itself. Now if you're interested in seeing me forge these in person, I'm down here every weekend now at the Jackson Arts Market in lovely downtown Silva, and I'd love to show you.
They cool down pretty quick, huh?
They do, they do. You get probably 20 or 30 seconds, but it's starting to get that shape.
Oh, I see. Nice.